All right, so welcome to CNCF Abuja Cloud Native Unplugged Meetup. This is the February meetup for 2025 and the second in the quarter. We're going to be having themes like this on a quarterly basis. So if you want to keep on, participating in exciting topics like this, do also subscribe. Today, we have really amazing speakers who are going to be giving us really exciting topics from getting into open telemetry and observability down to understanding service meshes in Kubernetes. And I can't wait to dive into all of the exciting updates from these speakers. And to begin with, I'll bring forth our first speaker, who is going to be leading us on getting started with Open Telemetry Collector. And our speaker is an amazing person, software engineer at Sematex. And so I know that there's a lot of inputs that we're going to learn from this session. So if you have any questions, like I said earlier, do also drop in the chat. Hello and welcome to our session today.
Hello, Anita. Thank
Hi.
you. It's nice being here. Thank you for the privilege.
It's great to
So
have you here.
do I just start now?
Yes, so you can start sharing your screen. There's a button at the bottom, share screen. You should have access
Yeah.
to that. You can just hit and then share your slides.
Okay. Cool. Can you see my screen?
Yes.
Okay. Cool. Hello, everyone. I am Eromosele Akhigbe, and today we'll be talking on getting started with the OpenTelemetry Collector. So, just a little disclaimer: this is a very beginner-friendly talk. So, staying. I'll be sticking with the basics so that I don't, carry you guys away. Yeah. So let's go. So, who am I? I am currently a technical writer at Step Security. What is Step Security? Step Security is a platform that helps secure your GitHub action workflows automatically. And 2 days ago, actually, I left Sematext, so I'm no longer a software engineer at Sematext. And I'm a former outreach intern at OpenTelemetry. For those that don't know Outreachy basically is it's an initiative, it's a company, non-profit organization that they want to encourage people, underrepresented people to enter open source. And as you can see from the picture below, fun fact about me, I'm a lead guitarist. I love the lead guitar. Yeah. So let's dive right in. This is the agenda for today. What is open telemetry? What is the collector, components of the collector, deployment modes, and yes, we're going to be doing a live demo. So pray for me. Yeah. So first slide, what is OpenTelemetry? Now, over and over again, there have been a lot of misconceptions about what OpenTelemetry is. I've read a lot of blog articles, and even some talks, and then you would see people talk about OpenTelemetry or give wrong ideas about OpenTelemetry. Like for example, now this young man in this slide thinks that he has to pick between Prometheus and OpenTelemetry. And it is not so. That is not what it should be. OpenTelemetry is not in competition with any monitoring solution. So what OpenTelemetry works with monitoring solutions. So let me just debunk some misconceptions that some people have about OpenTelemetry. So first of all, OpenTelemetry is not an observability backend. That is not a monitoring solution like Sematex, like New Relic, like Dynatrace, like Prometheus. It is not an observability backend. It is not a full-on solution in the sense that without a vendor backend, you can't really, you won't maximize the use of OpenTelemetry. So I just wanted to clarify that out there and leave it out there so that you know that. So when someone asks you what is OpenTelemetry or what is the difference between OpenTelemetry and Prometheus, you don't think you have to compare. You just tell the person that no, there's no comparison because they work hand in hand. Yeah. So what is OpenTelemetry? Let's go right in. OpenTelemetry, first of all, it's open source. And we all know what the meaning of open source is. So it means that you can, contribute to it, you can go through the code, and there's so much built around OpenTelemetry. So it's an open source of observability framework and toolkit that is designed to generate, collect, manage, and then export telemetry data. So that is what is in. I tried to find a very good definition, and this was what I saw could, should I say, compress the definition of OpenTelemetry, because OpenTelemetry is not just one thing. It is divided into these three things. So we have the protocols. So OpenTelemetry has three major components. We have the protocol, the instrumentation, and then the collector, which we're talking about today. But let me just give a brief overview about these other components. So we have the protocol. So before, in the ability world, how the data that you received or the data that was collected was dependent on the vendor backend. So for example, let's say I'm a company and I go to Datadog and I tell Datadog that I want them to set up observability for my system. There was a particular format that Datadog, received data in. So let's say tomorrow Datadog gives you a $1 million bill and you want to run away from Datadog, but then your application and everything, your whole system has already been instrumented with Datadog with that particular, format that they send data in. So you were stuck to Datadog. Like you couldn't just wake up and leave Datadog. It had to take months and if sometimes even years of planning. So, but with OpenTelemetry provides a standard protocol of sending and receiving data, and it's known as OTLP. OTLP. And it's called OpenTelemetry Protocol. So it provides a standard way of receiving data. So if I'm moving tomorrow from New Relic and I decide to move to Sematext, I have total control of my data because it is standardized. And we all know how things are, that when there is no standard way of doing things, things get really messy at some point. So that's what OpenTelemetry provided, a standardized protocol for sending and receiving data. So we have the second component of OpenTelemetry, which is the instrumentation. So I feel like this is like one of my most favorite components of OpenTelemetry because previously, if you wanted to instrument your code base, it took so much time, so much effort. And most times the engineers, in charge of the instrumentation will be looking at legacy code bases that probably existed before they were even born. So instrumenting those code bases were really stressful, really hard. But then with OpenTelemetry, there's something called and known as automatic instrumentation. So with automatic instrumentation, all you need to do is just to run an agent. This is how to do it. You define certain variables, and then you run an agent in the background, and it automatically instruments your full application without requiring any code change. So I don't need to touch any part of the code. All I need to do is just to run those commands, and then voila, magically, my application has been fully instrumented. And then we now have the final component that we're going to be talking about today, which is the OpenTelemetry Collector, which is also really, really popular component right now in our day. I've had some companies reach out to me, basically asking how to maximize the use of the collector in their observability infrastructure. But what the OpenTelemetry Collector does is that it provides a way to, with just a slight configuration change, you can stop sending your data to Datadog or any observability backend, and then you can begin to send it to whatever other observability backend. So let's say Datadog brings you a bill of $100,000. Sematext approaches you and tells you that if you send your data to us, we would give it at $40,000, so that you will be saving $60,000 with just a slight configuration change. You can simply move your data from sending your data to Datadog to Sematext. Okay. So, but today we'll be focusing on the OpenTelemetry Collector. Maybe in other talks, I'll probably go deeper into the rest of the components of OpenTelemetry. But today we'll be focusing on OpenTelemetry Collector. So what is OpenTelemetry Collector? It's a tool that collects, processes, and then sends your data from your application to a monitoring tool. So before I go to explain what's going to happen in this image, I want to paint a picture. I want to use an illustration to buttress my point. So imagine you have a 3-socket plug, or sorry, a three socket. Yeah, you have a socket that has 3 mounts, 3 pins, whatever, and then you want to plug your, let's say, Mac charger, and we all know that Mac chargers have 2 pins. And so naturally, you shouldn't be able to plug that Mac charger to the socket because it does not match. So what you would need is that you would need an adapter, something that can serve as a middleman that would change the that you can plug the charger into the adapter, and then you can still get current passing through to charge your laptop. So that's basically what the OpenTelemetry Collector is. So now we all remember when we spoke about the protocol that OpenTelemetry provided a standard protocol for doing things, that's OTLP. So when data is sent over OT, let's say you have an application, you've automatically instrumented this application, awesome. So this application now is sending OTLP. Now, some vendors today do not support OTLP, because remember from the very beginning, so from the very beginning, the vendors had a way that they supported data. So some vendors actually, like most vendors, have started supporting OTLP, so that issue isn't really there anymore. But prior to like 2-3 years ago, a lot of vendors didn't support OTLP. So what happens is that the OpenTelemetry Collector, to receive data in OTLP, and then remember the adapter example. It will now serve as the adapter, and then there'll be some kind of transformation done in the collector, and then it will now export that data in a format that the vendor can accept. So let me use real life things. For example, so the work I did in Sematext was that I was building an exporter for them so that they can transform OTLP data into influx line protocol data, so that they could receive it, or they could receive metrics data. So that is what the collector does. So it transforms that data so that the vendor can accept that data, and then you still have that standard data. So that's why I say that the collector came to change the game, to shake up the whole game. Yep. So let's go straight into this diagram. So we have these are the receivers. We have different types of receivers. So look at that. We have different types of processors. So what happens in the processors is that the processor just helps to process your data, add more things to your data, and then we have the exporters. Sorry that this image is cut. I know why. But let's look deeper into the components of the OpenTelemetry Collector. So from now on, I'll be referring to the OpenTelemetry Collector as Hotel Collector, like my shirt says Hotel anymore. Yeah, so it's a joke that we all do in the hotel space. So the components of the OpenTelemetry Collector, we have the receivers. Remember that image that I sent? So what is a receiver? A receiver is basically responsible for collecting telemetry data from different sources and then bringing it into the collector. So we have the OTLP receiver, which is one of the most popular receivers, because like I said, OpenTelemetry provided the standardized way of doing things. So the OTLP format, so you can send your data over OTLP format to the collector. And the beautiful thing is that once you instrument your application with OpenTelemetry, instantly, without any code change, without any stress, your application sends OTLP data. So the receiver collects that data. So we have different types of receivers. We have OTLP receivers. We have the file log receivers. We have HTTP receivers. We have host metrics receivers. And then the next component is the processors. So the processor is responsible for, like I said, modifying, filtering, batching, or enhancing telemetry data before sending to an exporter. So let's assume that before sending the data, you wanted to add some certain attributes. Let's say before sending the data, you wanted to redact some attributes. Let's say you had like some API tokens in the data, and you wanted to just take this off so that you don't send that to the vendor backend. So this is where you process your data and you make your data how you want it to be, so that before you send it. And then you can also do batching here. So what batching means is that you send your data in batches. so that you don't overwhelm the vendor backend that you're sending to. So we have different types of processors. We have batch processors, we have attribute processors, we have filter processors for filtering stuff, and we have memory limiter processors. Next component, we have the exporters. So what is an exporter? An exporter is responsible for sending processed telemetry data to a monitoring or a storage backend. So yes, you don't have to necessarily just send straight to the backend. You can actually send your data straight into storage and then assess that storage with a backend. I think there was a time that I had to do a demo for a team, and what they wanted to see was it possible to send data straight into a storage into storage without actually visualizing it. So it's possible to do that. So we have different types of exporters. We have so many types of exporters. We have OTLP exporter, which is very common also. We have the Prometheus exporter. We have Sematex exporter. We have the debug exporter. I have many exporters. So remember what the explanation I gave for an exporter with the analogy I gave. It just basically transforms OTLP format or whatever format is in the receiver to a format that the vendor backend can understand and can receive. Okay. Then we have one more component of the collector. When preparing these slides, I kept contemplating whether I should add this here, because it's not very advanced, but it's a step further. So we have two other components that I did not add to this slide. So one other component, we have extensions and we have connectors. So I won't talk about the connectors because that will take us down a full line, but I'm just saying it out so you can do your research, if you're interested. But what extensions are, they are optional components. So they are not necessary, they're not required in the collector. So they enhance functionality by providing different features like health checks and performance monitoring. For example, the health check extension provides a way for you to monitor the health of your collectors, and then the pprof extension basically provides a means for you to see the collector's performance. Provides an endpoint that you can assess the collector's performance and know how it's doing. So they are not very necessary, and even the live demo I did not add them because I didn't want to put too much complexity, but just to make you aware that these things exist. And the final component of the OpenTelemetry Collector is pipelines. So what pipelines do is that the pipeline is just basically a place to connect the receivers, processors, and exporters for each telemetry data. This is another big advantage of the collector. The fact that I can send different types of data into one place, and all I need to do is just define the number of exporters I have. So I can have like 10 different exporters. Well, that's a bit much, but you can have 10 different exporters, meaning that you can, with one data, the data that you're getting from your application, you can export that data to 10 different sources, to 10 different backends. So before the OpenTelemetry Collector, you did not have this kind of flexibility or control. So with the OpenTelemetry Collector, a company or an organization is in full charge of their data. It gives you control, total control of your data. So in the pipeline, this is where you define, so for traces, like we see in the demo, but for traces, you can define that, okay, I want to receive data in OTLP. I want these certain processors to process this data in a particular way, and then I want to export it, using this certain number of exporters. For example, you say that we exported the traces with OTLP and debug with the debug exporter, but for metrics, we did not export over OTLP, and for logs, we did not export over OTLP. So it gives you that control. So you can see that, let's say New Relic has very good metrics, solution, but you prefer Elasticsearch log solution or Fluentbeats log solution. So I don't have to force all my data into one backend. I can split it up. Let's say that there's a security issue. Let's say, God forbid, Dynatrace or Sematex gets hacked. You still have full control of the other sides of your data. Yeah. So Next topic, the deployment modes. And I just wanted to give a disclaimer that Kubernetes and I are still having like conversations about understanding each other. I think I've tweeted some time a while back that you can't spend so much time in the cloud native space and run away from Kubernetes. I have been running from Kubernetes, but it's seeming like I can't run again. So I'll have to confront my fear and face Kubernetes. But currently, my Kubernetes knowledge is very, very low. So I would speak from what I know, from the intro that I know. So basically, there are two ways to deploy, officially speaking, in the OpenTelemetry documentation. There are two ways to deploy your OpenTelemetry collector. So you can deploy it as an agent running as the same host as your application. So let's say you have an application that has already been instrumented, manual instrumentation or automatic instrumentation. I prefer automatic instrumentation, but there are certain custom libraries that you might want to instrument that you may need manual instrumentation. But let's say you have an application with OpenTelemetry instrumentation. So immediately you will know that the application can send data over OTLP automatically. And then you deploy the OpenTelemetry agent. So when I say OpenTelemetry agent, I'm talking about the collector. So deploying the collector as an agent. So you deploy it on the same host as the application, and then you now send that data to the vendor backend. So what are the pros of this kind of approach? The pros of this kind of approach is that there is, like, because they're sharing the same host, like there's more resilience, like there's reduced dropped telemetry data, and then there's no latency. There's little or no latency because they are both deployed on the same host. And then what are the cons of this approach? The Kubernetes guys know that there'll be increased resource usage because now you have to cater for the OpenTelemetry collector. And then secondly, there's less centralized control, meaning that you have to, let's say you have 100 hosts or 200 hosts, you have to configure each collector on each host. So those are the cons of this approach. And then the second deployment mode we have is the gateway mode. So when you deploy the OpenTelemetry collector as a gateway, you're not running it as an agent again. So you're running the OpenTelemetry collector as like a central service. So this is just one host, but imagine you had like several hosts, and then all of them are sending their telemetry data to one or several collectors, but the collector is defined is deployed as a gateway. Like, so it's one central place they're sending your data to. So I can even start talking from the cons, because you know that there's a single point of failure. So what happens when the collector fails? You can lose that data. And then what is the good side of things? Obviously, your efficient resource utilization. You're not spending as much memory, and then you don't have to worry about the configuration, because you just have one configuration point, to handle things. So yeah, so these are the two deployment modes, official deployment modes. But in doing my research, I found out that there's one extra deployment mode, and this is actually what is suggested when it comes to deploying the OpenTelemetry collector in production. But that's a full topic on its own. But I just wanted to say that there's one more mode, and that is what I decided to use for the live demo that I'll be doing next. So next, live demo. So guys, pray for me that this does not fail. Yeah, so you can access this live demo. I'll probably drop a link because I have it on my GitHub profile. So you can just simply access this live demo. And I did it in such a way that all you just need to do is to run Docker Compose and everything is running. You don't have to think about much. So basically, this is the architecture. Like, remember I told you about, there's one more way of deploying your OpenTelemetry collector, and that's using the hybrid approach. That's so you're both deploying the collector as an agent and you're deploying the collector as a gateway. So when you do this, what are the pros? You have the best of both worlds. So, for example, let's say the whole issue of if something happens to the gateway and this fails, you have the agent that's still buffering the data in the, running on each host, that's still buffering the data. and there's just so much more that can be offered here. Like you can do several processing. You can have, let's say you can have certain data that you want to add to each for every data that comes into your back end, or you can have specialized data that you want for each host. So like this just gives you the best of both worlds, basically. And what are the cons of this approach? Obviously, you have to manage all of this. But in the end, like I said, for production, this is highly recommended. If you want to deploy OpenTelemetry Collector to prod, this is the architecture that you should be looking to use. So for today, for the live demo, let me try and increase this so that you can see better. I think I have this. Okay, yeah, I already have this here. So you can just go to Akhigbe /OpenTelemetry demo. I already have this here, and you can play around with it. So for the live demo, I have a Golang application with OpenTelemetry instrumentation that's already been instrumented with OpenTelemetry, and I use manual instrumentation because using automatic instrumentation would have taken me to would have to discuss full a lot of things, and I wanted to keep this as basic as possible. So we have the first collector that is deployed as an agent. It receives data over OTLP and then does some processing of that data and then exports that data over OTLP. And then it sends this data to the OpenTelemetry gateway, which is also a collector, like I said. And that collector receives data over OTLP, does some more processing to that data, and then exports it to Jaeger. And then the data is now stored in Elasticsearch. So enough of English. Let's go down into the code. So this is my simple Golang application, very, very simple Golang application. It just has 3 endpoints, hello. Sorry, it just has 2 endpoints, hello and root. And then I enabled caching with Redis. But this is not what I want to focus on. I want to focus on the agent and the gateway. So remember what I said about, let me try to increase this so that you can see. Okay. Cool. Yeah, sorry, I just need to confirm that I'm not talking to myself. Anita, are you still there? Because I can't see anyone. Hello, Anita. Hello. Can anyone hear me?
Yeah, I can hear you.
What's happening?
Yes,
so I just
I
want to
can
confirm.
hear you.
Okay, cool. Let's sit together. Cool. So remember what I said about receivers, processors, and exporters. So this is how the configuration for your OpenTelemetry collector file should look like. It's YAML. Everybody loves YAML. To decide, but it shouldn't be 1 second because you have too much data at once and you're disputing the whole fact of getting a bad processor. So then we have the resource processor, and what it's doing that it's adding attributes. So let's say you wanted to add certain custom attributes to each data that you're receiving from your application. You can simply do that here. Do you have other types of processors? We have sampling processors that you can sample your data, and do so much more to your data. But I kept this as simple as possible. And then we are sending the data over OTLP to the collector gateway, because remember the architecture, this is the one for the agent that we're looking at currently. And yeah, remember the pipelines I spoke about. So currently I just focused on the traces, but you can send, I want you to know that you can also send metrics and logs and to whatever backend that you decide to. All you need to do is just specify it here. So you can specify metrics, receiver, OTLP, processor, whatever, and then you can send the data to Prometheus or New Relic or Dynatrace or whatever you want. And then the collector as a gateway. So Again, it's receiving over OTLP and some processing done again. And I added another attribute. So remember I said one of the pros of this approach is that I can add certain attributes per host, and then I can now add general attributes for the footer. And I'm exporting this to Jaeger. So now let's say you wanted to, I'm going to update this configuration, because currently, just to give you information, that this exporter has been deprecated and it has been replaced. So now Jaeger now supports OTLP, supports OTLP natively. So you don't need to use a Jaeger exporter, just a disclaimer. So that in case you're trying this demo or you're suggesting this for your employer, you know that Jaeger is not currently, there's no more Jaeger, it has been deprecated. Yeah. And then we have the pipelines again. So enough English. So yeah, and then this is my compose file. I have the app that I have already, Dockerized. We have Elastic that was sending the data, was storing the data in Kibana to view the data was stored in Elastic. We have Jaeger, and we have the collector, and we have the agent. Okay, yeah, there's one more thing I was supposed to talk about, but I'm going to talk about this after I'm done, with the demo. So now let's run our demo, and let's hope for the best. So Docker Compose up. So fun fact, when I was running, I was trying out this demo in the morning, and I realized that Docker was running on my system again, and I almost panicked, but happy that it's running now. Okay, cool. Interesting. Wow, that's very interesting. Sorry. Docker login. Man, live demos are the best. Docker Compose up. Okay, awesome. So we are receiving. So now everything has been set up. We can see the collector has been set up. The first collector, the second collector, Jaeger, Redis, everything is working. And our application is running on localhost 8080. So let's just localhost 8080. Yeah, very, very simple application, nothing stressful. So yeah, welcome to my Go application, and I think hello Redis. Cool. So now we can go to the Jaeger, because remember, this data is being sent to Jaeger. So let me reload this and find traces. And we can see, this is 1241, that we have our data in Jaeger. So cool. OpenTelemetry, so cool. And we have our data in Jaeger, and then you can open this up and then view the details of the span. And we can see those things that we added, those attributes that we added here. So you see, so imagine that you wanted to add so many more things. It is possible. Just specify them in the resource processor, and then you can have that instantly in your vendor backend. And then, yeah, I think this is it. You can also go to Elasticsearch, and then we can see this data being saved in Elasticsearch. Sorry. Yeah. So I think that is all for the live demo. And please, if you have questions, please definitely ask. And yeah, so there's one more thing I did not add to the slides that I said I was going to talk about. So installing the OpenTelemetry Collector, because some of you might be asking, how do I start? How do I install the collector? So just simply go to the documentation and follow it. Very, very simple to install. They have different ways of installing the collector, Docker or Kubernetes. I prefer Kubernetes. Sorry, Docker, not Kubernetes. Yeah. So I think that is all that I have for today. Thank you very much for listening. I'm sure you gained so much value. And if you have questions, please ask. Anita, over to you.
Oh, thank you so much, Eromosele. This was a really detailed one. And that is because I always had so many questions about how OpenTelemetry works. And mostly because whenever I hear about like OpenTelemetry, the first thing that comes to my mind is the logs, the traces, and I never
Yeah.
really see this other aspects of it, right? Because
Yeah.
in theory, this is all that they talk about in terms of OpenTelemetry, and this was a really different angle to it that, and I really enjoyed it. I just have one question. How is the data like interpreted for people? Let's say I want to, use OpenTelemetry and then go through like the logs and data. How is that interpreted, and how am I able to see it from the receiver's point of view?
So what do you I'm trying to understand your question. So what do you mean is that how is the data that you're sending to the collector interpreted?
Yes.
Is that the question?
Yes.
Well, so like we saw in the demo, the data we got was from the application. Remember the application that we did? This
Yes.
application. Yeah. So I have already done the instrumentation. I didn't go into that, but I've already instrumented this application to send that data. So that data is just raw. You can't understand it. But with the collector, like I said, what the exporters do is that it changes that data from OTLP to a format that Jaeger can understand. And it is that data that you now see here. Do you understand? So let's assume I did not use Jaeger. Do you have any platform that you're very familiar with, like Grafana or Prometheus?
Yeah,
So
Grafana.
Grafana. So instead of what you instantly see is that you begin to see your data exactly the same way you just appeared, like magic. You begin to see your data in that Grafana format. So you can begin to see dashboards. You can have access to that data. You can play around that data. So it's depending on the vendor backend or how they choose to display that data. Do you understand? Am I
Yeah.
able to answer your question?
Yeah.
Did I answer your
Okay.
question?
That makes absolute sense.
Yeah. Okay.
Okay. Any
Any
more
other-
questions for our speaker?
I'm scared when there are no questions. Was I too fast? Maybe I was too fast.
Perhaps you should think about it as you were too detailed and everyone completely understands. Oh, we have a
Okay.
question from Emmanuel.
Okay. Cool.
Good afternoon. I kind of joined late, so I want to ask where and when should we really use open telemetry? Like, what is the use case?
Okay. Well, I said it in the beginning, but OpenTelemetry has different components. So there's the protocol for OpenTelemetry, there is the collector, and then there's the instrumentation. So I don't want to go into that full detail, but basically, let me just focus on the collector. So when you should use the collector when, as an organization, you want to have full control of where your data goes to. So you don't want to be stuck on one particular vendor. You don't want to be stuck on, I know, I'm sure you guys have probably seen these whole trends about Datadog pricing, where companies are spending $800,000. And in short, it's fact that after cloud cost, observability costs are one of the most expensive costs for companies. So companies are looking for how to reduce cost. So you use the OpenTelemetry Collector when you want full control of your data. So that's when you use the OpenTelemetry Collector. Did I answer your question, Emmanuel?
All right, thank you. Thanks.
Okay, cool.
Okay. Do we have
Any
any
more
other
questions?
questions? Okay. So, in case you come up with or like your question that you were supposed to ask, and the maybe this is all over, you can also reach out to our speaker via socials, and
Yeah,
I'm sure they'll be happy to share it in the chat, so you can also connect to them there.
yeah. Thank you so much, Anita.
All right. Much for that great presentation, and I enjoyed every bit of it.